Okay. Now, ladies and gentlemen, this is what we are doing today. We are looking at the computer output regression analysis. So I share. So this is the question that I would want us to do today. It is August 2024. Yeah, August 2024. Question number 2. Boy, Plasma Electronics Limited. Plasma Electronics Limited supplies digital decoders and liquid electronic display television sets for high-end users. Customers contract Plasma Electronics Limited with request for maintenance of their terrestrial signal frequency. To estimate the service cost, Plasma Electronics Limited wishes to predict the installation time in hours. They wish to predict the installation time in hours, the dependent variable necessary for each maintenance request. Installation time is believed to be related to two factors: the number of months since the last maintenance services and the type of the maintenance problem, whether digital or analog. Regression analysis, the time versus months type. Yeah, so we are told here we have the predictor, constant, months, type. Coefficients are given here, standard error of coefficients, and then they have given us the T ratios. So we have here S, 0.45, 90, 48. We have whatever R squared. Then we have R squared adjusted. Analysis of variance ANOVA. They have given us degrees of freedom, sum of squares, mean sum of squares, and then we have F. So they want us to write down the linear regression equation model, 2 marks. Then we find the missing values of XA, XB, XD, and XE. Explain the statistical meaning of the standard error of estimate, this one here, R squared, this one here, and the F statistic given here. Using the economic plausibility test, is the regression model significant as a predictor variable? So, ladies and gentlemen, we shall start right away with this part. Yeah, write down the linear regression. Linear regression, of course, we are using these coefficients, my good students, these coefficients here. But you see, there is an unknown factor. There is an unknown coefficient. So let's skip number 1. First of all, we do number 2 and find out all the missing values. Once we find out all the missing values, then it will be very easy for us now to write down a regression equation. Ladies and gentlemen, remember that generally, regression is used to develop equations of this form, if you recall. So generally, regression is used to develop equations of this form. So generally, regression is used to develop equations of the form y equals a plus bx. So you can see, ladies and gentlemen, this is applicable in simple situations. This is what we call the simple regression. Simple regression model. The simple regression model. And then now, like the question that we have here is multiple. So why are we calling it simple? Because it has only one predictor variable. But in most cases, it will have like 2 of them. So 2, it will be y equals a plus b1 x1 plus b2 what here? X2, like that. Yeah, so this is what here? This is multiple regression, because we happen to be having 2 predictors. X1 and X2, those are the predictor variables. So it's multiple regression. So actually, this is not the point, because for the first part that I would want us to handle, we don't even have to know the general form. The first part that I would want us to handle, ladies and gentlemen, wants us to find unknowns. And to find unknowns, we shall use, in this case here, the T ratio model. Yeah, the T ratio model. And then, of course, under the ANOVA, there is also a formula there. So in this case here, first of all, let's use the T ratio. Is there somebody who could be remembering how we normally calculate the T ratio? Anybody who remembers how we normally calculate the T ratio? T ratio. Anybody who could be remembering how we normally calculate the T ratio, please help. T ratio equals something. In regression, is there somebody who knows how we normally calculate the T ratio in regression analysis? I will not talk until you give me a solution. I will not talk at all until you give me a solution. The T ratio equals something over something. Thank you so much. So they're telling me, Mwalimu, this one we know, T ratio. Anytime they want us to get this student's T ratio, it will be equal to coefficient all over the standard error of the coefficient. So then we come to our question that we are sharing. Thank you so much. I can see you guys, you're already on top of things. Yeah. So you can see where we have the missing, this one. Where we have the missing, yeah, the T ratio is given. The T ratio is given. So is there somebody who can give me this value of XC? Let me give you 1 minute. Because they have given us the T ratio, let me give you 1 minute. Remember, this is special revision. Special revision, we are making an assumption that you did your exams last semester. Already you have the content with you. So here it's about Mwalimu just enabling you to answer these questions. Waiting to see whether there is anybody who will be able to get the T ratio. T ratio. Is there anybody who will be able to get the T ratio? Thank you so much. Thank you so much. I can see there are trials here. You see the T ratio here is 4.02. The coefficient is not given, but we know the standard error. So in this case here, we come and plug in. So you're saying that the T ratio is 4.02. The coefficient is what is being provided, or rather is what the examiner wants you to calculate. All over the standard error. So standard error, ladies and gentlemen, I just have to reshare back this for me to confirm that the standard error you can see for this, the whole row, is 0.3141. 0.3141. Yeah, 0.3141. So you have here 0.3141. And therefore, XC will be equal to, 4.02 times 0.311 if you cross multiply, which at the end of the day will end up giving us that great answer that most of you, 18 students were able to get it right. Yeah, 1.26, 1.2626, like that. Great. Great. So is that good enough, ladies and gentlemen? Then we have to agree whether you guys want us to round off to 2 decimal places or 3. We have to agree. Or 4. So that we will be able to be uniform, all of us. How many decimal places do you want us to work with? Remember, the more the better. Minimum 3. Yeah, let it remain 4 like that. Thank you so much. All right. So then we look at the others. So the others that we have there, still we are answering Roman 2. So Roman 2, like now you can see here, there is an XE. Can somebody tell me what do you think are we going to do to be able to get this XE? XE, somebody abracadabra. Please, no, there is an XB. Sorry, there is an XB here. There is an XB. Let's first of all get this XB that I'll be able to do very fast because I can see it is for this month row. For this month row, already we know the formula. I don't even have to give you time to do it because I've seen you guys are very good. So for this month row, I can see the T is 6.20. The T is 6.20. The coefficient has been provided as 0.38, 762, all over the standard error, and the standard error there happens to be XB. So then yours will be to make XB the subject of the formula. Yours will be to make XB the subject of the formula. So come and cross multiply, so it will be 6.20 XB equals 0.38762. Therefore, XB will be 0.38762. Divide this by 6.20, which ended up giving you, ready guys? You're getting, So let's get XB first. Let's get XB first. So XB, they are getting 0.0625. 625. And I believe all of them would have been able to get it. Is that okay? I hope that is okay for everybody. Okay. I hope that is okay for everybody. Then we have this XE. XE. So then can you kindly tell me what is the value of XE, somebody? If you don't know how to explain, just tell me the answer. If you don't know how to explain how to get it, just tell me the answer. Just tell me the answer. And that is straightforward because, ladies and gentlemen, you can see like for them to have gotten this totally, they're even giving you. For them to have gotten this total of 9, they took 2 plus 7. Yeah. So to be able to get to this, so it will be this plus this equals this. So I can write this down. Yeah, so you're saying that 9.0009 plus XE equals 10.4760. 10.4760. So then, ladies and gentlemen, in this case here, at the end of the day, our XE, if you take this XE to the other side of the equation, our XE will be 10.4760 minus 9.0009, which will end up giving us what figure? Already they had given me an answer. So XE is 1.4749. 1.4749. Are we in agreement about this, first of all, before we do the one Lillian wants us to do? Are we in agreement regarding XE? XE, yes. XE is like that. And ladies and gentlemen, we come straight away to this one here, XD. So like XD, what do they want us to do to get XD? Remember, this XD stands under what we call mean sum of squares. Mean. Actually, they normally write it wrongly. It's supposed to be MSS. MSS. Mean sum of squares. Mean sum of squares. Mean sum of squares. So to be able to get this mean sum of squares for XD, for us to be able to get this mean sum of squares, MSS, we normally take sum of squares given over degrees of freedom. Yeah, in short, MSS equals SS over DF. Yeah, very, very important. Very, very important. Already I can see students who have been able to get this right. So if you look at this question very well, ladies and gentlemen, you will be able to see these here. You'll be able to see these here. That MS, mean sum of squares, is what is required. So XD will be 9.0009 divided by 2. This XD. Yeah. So in this case here, we have this 9.00. So we have here, this XD is the MSS. It will be 9.0009 over 2 degrees of freedom, which in this case here, somebody has been able to give us an answer. Somebody is giving us 4.5045. 4.5045 like that. Thank you so much. Do we still have any other thing to do? Do we still have any other thing to do? No. I think for Roman 2, that's over. Roman 2, that is over. So now we can go back to Roman 1, where they wanted us to write down the linear regression equation model. Write down the linear regression equation model. Yeah, so write down the linear regression equation model. Very easy. So remember here, we have 2 predictor variables, x1 and x2. 2 predictor variables, x1 and x2. Yeah, so 2 predictor variables, x1 and x2. So we have here y equals a plus b1 x1 plus b2 x2. So remember, this a is the constant coefficient. This a is the constant coefficient. It is the y-intercept, so a has been given to us. So a is 0.93050. So a is 0.93050 plus b1. b1, I can see the coefficient, this one here, coefficient, 38,762. 762 x1, and then plus b2. Is there somebody who is able to remind Mwalimu what we got as b2? Anybody who is able to remind Mwalimu what we got as b2? Not b2, but x2. This one here. For the missing. We got this value. We got this value. We got this value. We got this value, x2. X2, we got it. 1.2627. 1.2627. So plus 1.2627 x2, like that. X2. So that is what you are required to do to get, ladies and gentlemen, in this case here, those 6 marks. That is what you are required to do to get those 6 marks. So should they bring, because you can see this is very, very popular, should they bring this kind of a concept this time around? Can you promise Mwalimu that I may not get everything, but at least I will be able to get minimum, say 6 marks. So are you able to see some light at the end of the day? Some light at the end of the day regarding this? Because they are not as bad as students were telling me that Mwalimu, this one is very, very bad. No. Great. So at least I move a bit here. So at least in this case here, they are confirming Mwalimu, this one, if it comes, out of 20, I will be able to get minimum 10. Minimum 10. All right. And then now we should be able to straight away look at this part. The next part in the question, ladies and gentlemen, that they're asking us to do, they want us to explain the statistical meaning of the standard error of estimate. Yeah, this one here. You see, we have the standard error of the coefficients, and then we have the standard error of estimate. So whenever you're told here to describe standard error of estimate, an error is an error. An error is a deviation between actual and what you predict and the predicted. So any error, it doesn't matter, any error, an error is an error, ladies and gentlemen. Anytime they tell you to predict or rather to describe a standard error, this is what you shall always tell them. So whenever they tell you to define a standard error, yeah, tell us there that standard error measures the average distance. measures the average distance, measures the average distance between the actual observation, between the actual observation and the predicted value, and the predicted value, and the predicted value. So it measures the distance between the actual observation and the predicted value, If I was to draw this, if, for example, we have our scatter diagram, if we have our scatter diagram, we have our predictions, our y equals a plus bx. So if you're predicting like this, and then you come and plot some actual figures, So anytime you are measuring the distance between this actual and this is the error term. This is the error term. So tell us there that the lower the standard error is, the lower the standard error is, the better the predictive model is. The lower the standard error is, the better the predictive model is. The better the predictive model is. So if you're given two models, please listen. If you're given two models, so we have here model 1 has a standard error of say 0.9, and model 2 has a standard error of 4.5. Always in this case here, pick the model with the lower. Pick the model with the lower standard error, because the lower or the smaller the standard error is, the better the predictive ability of the model is. So in this case, ladies and gentlemen, in our case, the standard error of the model, we're writing there in this case, the standard error of the model, the standard error of the model is 0.459048. The standard error of the model is 0.459048. So we will not be able to compare it with anything else. We haven't been given another standard error from another model. So it will be very hard for us to make any comparison. The most important thing, ladies and gentlemen, was for us to explain the statistical meaning of the word standard error. Standard error is the distance between the actual and the predicted. Yeah, it is that deviation. Yeah, deviation, distance between. The moment you describe like that, and then you say that the lower it is, ladies and gentlemen, the better the model is in terms of prediction, then you are good to go. Then from there, ladies and gentlemen, they want us to estimate, or rather to describe R squared. R squared. So please write there R squared, then you underline. And then we should be able to do what here? We should be able to describe it. We should be able to describe it. So once you've been able to write R squared title, remember it is 85.94%. It is 85.94%. 85.94%. Right? So we have here, this R with square is 85.49%. So what does this mean? It means, first of all, that this model is excellent. In terms of prediction, this model is excellent. Because 85 is very high. 85% is really, really very high. Yeah, it's excellent. Whatever predictions will give us, they'll be very accurate. All right. Ladies and gentlemen, once you have written like that, then remember that this R squared stands for what we call the explained variance proportion. The explained variance proportion. Again, the higher it is, the better. the ability of the predictive model is. The higher the R square, the better. The higher the R square, the better the model is for prediction. The higher the R square, the better the model is for prediction. Now, but yet you haven't explained, but I like students starting like that because you'll end up getting all the marks without even knowing what you're doing. Now, ladies and gentlemen, in this case here, remember, this gives us the percentage that can be explained by the two predictor variables. Yeah, so in this case here, this means that x1 and x2, in short, predictor variables, yeah, can explain 85.49% of the changes in the predictor, in the response variable. And really, this is very good. So approximately 14%, 14% is explained by variables that are not in the model. What we call exogenous. Yeah, that are not in the model. Yeah, this 14 is still allowable. Don't start burning your resources looking for that other variable to make this 100%. No, 85% is still well accepted. So, ladies and gentlemen, up to here, have you been able to follow? Have you written whatever we have been able to describe? Have you written? Great. Don't let me down. Because whenever they bring these questions, all of them in this case here are what here? They are the same. They're the same. You'll never get like a regression question that is really very different. No. Yeah, the standard error amount. Standard error amount, the one that was given. Yeah, this one here. The standard error figure. It's not an amount, it's just a figure. 0.45, 90, 48. It's called the standard error of estimate for the whole equation. Yeah, we could not mention whether the equation is good with it or not, because for standard errors, we expect to be given like 2 or 3 equations, and then we compare figures. We take the one with the lowest. So I hope that is helpful. We haven't yet finished all our explanations. We've been able to do standard error, we've been able to do R squared, and we've been able to do, in this case here, or rather, now we need to do F statistic ratio explanation. F statistic ratio, very easy. Remember, I told you that we have got 2 types of hypothesis tests. We have a hypothesis test, for various variables, for the variables that we have. And that hypothesis or a significance test, hypothesis like this. That significance or hypothesis test is what we called, or rather we said, we shall be using what we call the T statistic when we are looking at individual components. You know, an equation is y equals a plus b1 x1 plus b2 what here? X2. So if you start looking at individual components, how significant are they? Then you use, in this case here, T ratio. Use T ratio or T statistic. T ratio or the T what here? Or the T statistic. But now, ladies and gentlemen, whenever you are looking at the whole equation, in this case here, we shall use what we call the F statistic. Once I have that general information, it will be very, very easy for me to pin down this examiner. Yeah, tell the examiner that F statistic F statistic is used to evaluate the significance of the whole equation for predictive purposes. The whole equation. So is the whole equation significant? Yeah. And then remember, if I were you, I would cram. First of all, the formula. Is there anybody who knows how we normally compute F ratio? Anybody who could be knowing how we normally compute F ratio? Somebody remind us, how do we compute F ratio? Anybody who can just remind us, how do we compute this F ratio? They must have forgotten because they are not writing. The formula is only 2 students. It's only 2 students. It's only 2 students. It's only 2 students who are able to confirm the formula for getting F ratio. Now there are 3. Now there are 3. Now there are 3. Thank you so much. Yeah. Thank you so much. Yes. Thank you so much. Thank you so much. Remember the formula for getting F ratio. These are the things you write to demonstrate broad and deep understanding of the subject. So in this case here, we have explained. Yeah. MSS, explained, mean sum of squares, all over unexplained. All over unexplained. Mean sum of squares. Explained, mean sum of squares, all over unexplained, mean sum of squares. Now, if you remember from the analysis of variances, ladies and gentlemen, that we introduced here, we said, whenever you look at analysis of variances, this ANOVA, you always have 2 types of variances. We have regression, which is explained. Regression is explained, and then we have the residual error, which is unexplained. And then we have the mean sum of squares. So let me write this. So we are saying here the types of variance. So we have here types of variance. There are 2. We have regression. Regression is what we call explained. And then in this case here, we have error. Error is what we call unexplained. And if you look at keenly, the examiner has given us the MSS. The first one was unknown, but we were able to get it as 4 point. Can somebody in this case here remind us the mean sum of squares? For the explained, for the regression, we had already been able to get this. 4.5045. This means sum of squares, XD for the regression. So we have in this very good. So we have 4.5045. 4.5045. How about the unexplained? This has been given there as 0.20 something, Yeah. The unexplained MSS has been provided. We can share the screen again for us to be on the same page. Yeah, you can see it is 0.2107. 0.2107. 0.2107. 0.2107. So then I can easily get this F ratio. To get this F ratio, we normally take 4.5045 all over, in this case here, not normally, but we normally take the explained mean sum of squares all over unexplained mean sum of squares. Can somebody in this case here give me the final answer? Nobody told you to calculate it, but you want to demonstrate that you have gone to a good school. Yeah. 21 point something, isn't it? 21.36, 21.36. And you can see now this is what they did to get that F. This is what they did to get that F. Ladies and gentlemen, tell us there that the model is significant. The model with that 21.6. Now, the rule of the thumb is that whenever you get this being more than 3.98, this is what we call the F tables. You can just cram it. It will not be given sometimes. So if it's more than 3.98, it means that the model is very significant. Yeah, very significant. So in this case here, the model is very significant here. The model is very significant. The model is very significant because you can see how big it is. We expected it to have something close to this, the threshold, but now 21.36 is really huge. So the model is very significant. The model is very significant. So remember they told us just to explain, and we've even gone ahead to show them how we calculate it. And even we have gone ahead to measure the significance of the whole equation because there is this 3.98 benchmark figure that is expected of you. Of course, for you to have it inside your head, the oblongata, isn't it? Medulla oblongata, yes. You cram it, 3.98. So is that okay, ladies and gentlemen? Can I move on now to something different? Can I move on to something different? Yeah, great, great. Now, my good students, the next one they want us to do is to come and test the economic plausibility test. Yeah, the plausibility test of the regression model being significant as a predictor model. Now, we have in this case here plausibility. Plausibility test basically means what here? Are the variables in the relationship making sense? Yeah. If you go, for example, and I get in this case here, this kind of a relationship, and I gave you this example in our last class. Yeah. For example, effectiveness of an accountant versus the size of the toe. The size of the toe. Are the two, in this case here, really variables related? Are they related? Are they related? Are they related? That there is somebody who is making a very bad hypothetical statement, hypothesis statement, that in this case here, the bigger the toe that you have, I hope you know what the toe is, kidole kubwa ya mguu. That the bigger the toe, the more effective you are as an accountant. No. This kind of a relationship is what we call spurious. Spurious like this. Spurious. Spurious means what here? Nonsense. Means nonsense. Means nonsense. It means nonsense. Nonsense. Spurious. I should never use any spurious relationships, for purpose of prediction. That will be very, very bad. Spurious means nonsense. Because, ladies and gentlemen, you can still be an effective accountant even without a leg, leave alone a toe. I've seen people without legs, in this case, you're still doing financial reporting excellently. So this is really nothing that speaks any meaningful predictive model to us. So it is called what? Spurious. Spurious. The opposite of spurious is plausible. Plausible. For example, ladies and gentlemen, if you're given this kind of if you're given this kind of relationship, we have here, maize, output of maize as a function of rainfall. As a function of rainfall. But in this case here, of course, we know the higher the rainfall amounts, the better the harvest will be. So this makes sense. This makes sense. But again, remember, you have to be very, very careful. There are days you'll go to an exam and then you realize that the examiner is telling you that rainfall depends on, in this case here, output of maize. Output of maize. Is it true that rainfall can really depend? I mean, rainfall is an act of God. Even if you decide to plant bang and God decides to bless it and pour rain, it'll still pour. Even if it's a desert, there is no possibility of rainfall ever depending on the output. It's the other way around. So if he tries to mix this up, then automatically that will make this one here a spurious relationship. But now this one here is what here? This is plausible, practical, feasible, like that. So it will be very, very important for you to just understand your variables in an equation. Once you understand your variables in an equation, then you are good to go. However, at times like now, the one that we are doing here, at times they may not really even make lots of sense. But for our case, already we have our equation, y equals a plus, and both of them were positive. If you want full marks, you go and say that the relationship, even without checking a lot, the relationship is plausible since x1 is positively related to y and x2 is positively, or even if it was negatively related to what here to y, because your examiner at this level, he will never give you spurious equations, never. I've never seen it myself over the last about 24, 25 years I've been teaching. He will never give you spurious. He cannot give you a nonsense equation. He'll always give you equations that make sense. So for 3 marks there, you should always say that this is what here. You should always say that this is making what here. It is making sense. It is making sense. It is making sense. Let's try to analyze our model. So when you look at our model, ladies and gentlemen, so first of all, we must understand what really these variables are. So our variables are months and type. And I've seen both of them. In this case here, I've got what here? Both of them are positive. We wrote it down. Let's try to see in this case here, our y is the installation time. Installation time, is believed to be related to 2 factors. The number of months since the last maintenance services, and the type of maintenance problem, whether digital or what here, analog, the type. So you can read from up here to understand. Plasma Electronics Limited supplies digital decoders and liquid electronic display television sets for high-end users. Customers contract Plasma Electronics Limited with request for maintenance of their terrestrial signal frequency. To estimate the service cost, Plasma Electronics Limited wishes to predict their installation time in hours, the dependent variable necessary for each maintenance request. So installation time is believed to be related to 2 factors: the number of months since the last maintenance service and the type of maintenance problem. The type of maintenance problem, whether digital or analog. So let's write the equation. So our equation that we have down here, ladies and gentlemen, is y equals a plus b1 x1 plus b2 x2. This is the equation that we have. This is the equation that we have. So we have here y equals a plus b1 x1 plus b2 x2. So our y, if you remember very well, already we have this equation. Already we have this equation. We have it, yes. Yeah, we got it from these coefficients, like constant is 0.93, 0.50. Constant is 0.93, 0.50, plus B1 there, I can see, is 0.38, 762. 0.38, 762, plus, in this case here, B2. B2 is what we calculated here. Is there somebody who can give me what XC figure we got? Anybody who can just read for me this XC. Yeah, 1.26 whatever, 1.26 whatever, X2. Yeah, this was X1, like that. So meaning in this case here that installation cost equals 0.933050 plus 0.38762 months plus 1.263 type. So meaning that months are positively related to installation cost. Months are positively related to installation. Tell us that this is plausible. This is plausible. Because you know which months are they talking about? The months, I mean, from the last installation. So if from the last installation you have taken longer, before calling us, we shall charge you more. So it means that the more the number of months, in this case here we expect, ladies and gentlemen, the higher the cost. So the positive relationship there makes sense. So it's plausible. It's a plausible relationship. So in this case here, type. So type in this case here, I can see a positive relationship. Yeah, I can see a positive relationship. Remember type, it's between what and what here? It's between digital. Yeah, if you read there are two types. If you read here, there are two types. Which types are these, my friends? The types here, there are two types. Yeah. Two factors, his last maintenance service and the type of maintenance problem, whether digital or what here, analog. So now here they are not very, very clear. You know, at times they can be very fast for us to fix a digital problem. And of course, in this case, it can take us what here, longer, if you are working on what here, an analog problem. So if it takes us longer, yeah, to maintain, then the maintenance cost here will be what here, will be increasing. And because it is positively related, what we shall do is to make an assumption. Here you have to make an assumption because you see the type, we expected that if the installation is digital things, of course, they could be also expensive, but at the end of the day, they should be able to take us a shorter time to maintain. Just like, for example, you guys are learning on a digital space. That is why even your classes are cheaper. Digital things, they're supposed to be more efficient and cheaper. So in this case here, we shall make an assumption that so it's a positive relationship. And if it's a positive relationship, according to me, it can only make economic sense. This can only make economic sense if the analog type was encountered during sampling. So if it is the analog, it means that the positive relationship is plausible. If it is digital, the positive relationship then could make this what here? Could make this not really make lots of what? Lots of sense. But the moment you write it like that, let me tell you a secret. Whenever they ask about this plausibility, you simply don't even want to know so much. You come and say that the gradient here is positive, so it is positively related to the y. Say this is plausible. The gradient here is positive, so meaning that x2 and y are positively related, you say it's plausible. Without a lot of explanations, you'll be able to get all the marks there. After all, students don't write so much in this kind of questions. They don't write so much in this kind of questions. So is that okay, ladies and gentlemen? Is that okay, ladies and gentlemen? Have you been able, it's not about perfection. Perfection is very costly. If you go for perfection models, you will never really succeed. Even as a lady, if you want to be perfect as you're doing your makeups, I'm so sure you'll not be able to get out of that house. Yeah, if you can reach 80, 60, 70%, you walk out. Yeah. Yeah, at least you've known how to do the F, you've known how to do whatever. Yeah, so like the digital part, ladies and gentlemen, remember if it was digital, taking shorter time, then it would mean that it would have had what here? Negative relationship with this. It would have negative relationship. But if you start now making that kind of an argument, you may lose marks. The best is to say that this thing is positively related, the type is positively related to that, it's plausible, and you'll be able to get whatever marks were allocated on the question. So is that okay? And if it's okay, ladies and gentlemen, then in my next class, I will be able to start on what we call learning curves. Learning curves. The students in this case who haven't made a choice to join RCM, this is the place. And this is our number. Call us. Yeah, please call us and we shall be able to teach you this most interesting subject. So my next class, which will be tomorrow, I'll be starting with learning curves. And then tomorrow, of course, now we'll be able to go full. So it's my hope we've been able to pick something out of this session. And bye-bye. See you again tomorrow. Yeah, we shall be able to upload them in the LMS. They're recorded. Like this one has been recorded, yes. Yeah, great. Welcome, Brother Milton. Bye. All right, Mercy, bye.